So I'm going to prove. You can see the solution. Okay, so okay, for those who just joined the class, we are doing page number 166 3a, and in this theorem your given is like this: P and Q are the midpoints. The line has been created by joining these midpoints, so PQ is of course parallel to line BC, and we are supposed to prove this X is also a midpoint. This is not told by the equation. Only P and Q are the midpoints right now, but we are supposed to prove X also midpoint. Question is asking like this. Yes, if it is yes, then how? We are supposed to show that, and to show this how, we are going to do one theorem here. So you can see here it is statement, and this one is reason. Okay, first what we are supposed to do is, if we in number one we are going to write here, because P and Q are the midpoints, so we can say PQ is parallel to BC. So why PQ is parallel to BC? The reason is because PQ is line joined by by midpoints. Okay, so since PQ is the line made from the joining midpoints, PQ is going to be parallel to BC. Now you need to understand one thing. So in number two, if PQ full line is parallel to BC, then why not PX is parallel to line BD also? Isn't it? That means if full line is parallel, see here, just understand from the figure. Okay, full line is parallel, that means this portion will be also parallel to BD. So we have to write PX is also parallel to BD. Let's not write BD, BC. PX is also parallel to BD. So the reason for this is because PX is part of PQ and BD is part of BC. BD is part of BC. Okay, now one thing. Now X is going to be the midpoint. See, P is already midpoint. If this is midpoint and this is already parallel, then this X is definitely going to be the midpoint. So now in third statement, you can simply write X is midpoint. Now what is our logic? Why X is midpoint now finally? Because the reason is because P is midpoint, and PX is parallel to BD. So this is the hence proof thing. Okay, so only this much three statement for this question. Okay, this is the full solution of this question number 3a. Just this triangle PQR is an equilateral triangle. It is given by the question. It's clearly told by the question that triangle PQR is an equilateral. Means all this PQ equals to QR equals to PR. And another thing given by the question, this X, Y, and Z. This X, Y, and Z are the midpoints. These are the midpoints, and they have been joined also. You can see in the diagram. So now what we are supposed to do is prove that XYZ is also an equilateral. Now we are supposed to prove this XYZ is also an equilateral triangle. Now how can we say this is XYZ is an equilateral triangle? Okay, this question is not going to be that much hard. It's very simple. So just wait and watch. I'm going to show you the solution. Okay. So you are going to write triangle PQR is an equilateral triangle. And number one given, and number second thing is given. X, Y, and Z are midpoints. So why they are telling midpoints? Because of course this theorem is going to be based on midpoint theorem. So what you are going to do, as this PQR is an equilateral triangle, okay, to prove is triangle XYZ is equilateral triangle. Okay, now you need to understand one thing. To prove any triangle equilateral triangle, we need to prove this all sides value should come same. So let's write that also, it will be more clear. we are going to, our target is going to be xy equals to yz equals to xz. Okay, so this is the thing we are going to prove. So now see here, what you need to understand. Okay, I'm going to draw one table. This is your proof table. So statement, reason. Okay, number one, first you have to do aq equals to qr equals to, okay, this is not aq, sorry, this is pq equals to qr equals to pr b. Okay, let's suppose this all sides are equal, that's why we are going to suppose it as x centimeter. So this is also going to be x centimeter, this is also going to be x centimeter, and this is also going to be x centimeter. And you can, the reason for this is we are supposition. Okay, just let's suppose, this is just let's suppose, no reason for this. Okay, number two, we are going to find the value of xz. So xz is, okay, xy, sorry, xy is going to be half of whom. So now you see from midpoint theorem, according to midpoint theorem, okay, I'm going to rotate this figure and you will understand. So see here, if x and y are the midpoints joined, so don't you think xy is going to be the half of this pr? So let's write it is half of pr. So xy value is going to be half of x centimeter. So because pr value is x centimeter, so you can write midpoint theorem. Okay, simply write midpoint theorem according to midpoint theorem. And number three, you are going to write, okay, after finding for xy, now let's find for yz. And you will notice one thing, yz value is also going to be same, but yz value will be derived from, yz is going to be half of whom. So yz को baseline कुन छ, this pq छ नि हैन, so it is going to be half of pq, and fortunately the value of pq is also x only, so this value also came same, and the reason for this one is also midpoint theorem. So in this way, the third side will also come the same after getting all sides same value. So yz is also done. Now let's find for xz finally. So xz is going to be half of, you can see the diagram, it is qr, and fortunately the qr value is also x centimeter, and the reason for this one is also midpoint theorem. Finally, since all side became equal, you can write xy is equals to yz equals to xz came same. So the reason for fifth number is from statement 1, 2, no, not 1. Okay, yeah, 1 also, because 1, 2, 3, and 4. So why they all became equal? We can see that thing in 1 became x, and 2, 3, 4 all value came same. So you simply write the reason for fifth number is taken like, and then finally your thing is proved. So hence proved. So this theorem just this much only. Okay, in this question, the given is dq equals to qc. QC, that q is midpoint. This is one given, and second given thing in this question is PQ is parallel to AD and also parallel to BC also. So you can see this entire figure in two different triangles where R is the common point. And to prove is, two things we are going to do in this question. First prove is QR is equals to half of DA, and second thing that you are going to prove is AD plus BC is equals to, okay, 2PQ. Okay, I'm going to do a quick solution based on midpoint theorem only. So this theorem is also going to be based on midpoint theorem. Okay, you can see statement and reason. So number one, what we are going to do is we are going to write this. Okay, according to the question, full PQ is parallel to AD. Okay, what you need to write, full PQ is parallel to AD. What is the reason? PQ is parallel to AD. The reason is simply given. So now you need to understand, if PQ is parallel to AD, then of course QR is also going to be parallel with QR is also going to be parallel with AD. So what is the reason is because QR is part of PQ, isn't it? Yeah. So like my full length is parallel to this AD, then of course this portion is also going to be parallel. So simply written that after this thing is already parallel and Q is midpoint, then R is also midpoint. So R is midpoint. So how can we say R is midpoint now? So like in our previous theorem, because Q is midpoint, because the reason is there are two conditions has been already filled, because Q is midpoint and QR is parallel to AD in these statements, then that's why R is also midpoint. So now after proving R is midpoint, so this is the line made from joining two midpoints. So when any line made from joining two midpoints, then this line is going to be the half of AD. So you can simply write QR is equals to half of dA. This number one is proved. So you can write midpoint theorem. Okay, so this is your question number one. Now there is another question also we have to prove in this question. That is AB plus BC is equals to going to be 2PQ. So now to prove AB plus BC equals to 2PQ, let's find the value of uh, sorry, okay, this is not AB, this is ADA, sorry. So AD, let's find the value of AD. So AD is actually, so we are going to do from, let's write AD is going to be the double of what? PQ, right? AD. So if you see from this triangle, okay, let's write the title also, it will be more clear. In triangle ADC. So let's focus in triangle ADC. ADC. AD is going to be double of, because baseline is going to be double of this PQ, right? So this is also based on midpoint theorem. This is fourth statement, midpoint theorem. This is fifth statement, sorry. Midpoint theorem. This is in this triangle, right? So now we are supposed to find the value of this BC also. Now to find BC, the length of BC, you have to focus in another triangle, that of one triangle. So write like that. In triangle ACB, BC value is going to be double of PR. So this is also midpoint theorem. Okay, now we are going to prove. Now according to the question, we have to get this equation, isn't it? This is our target. So AD plus BC, now we have to add AD plus BC is going to be 2PQ plus 2PR. 2PQ plus 2PR. The reason for this is adding 5 and 6. Okay, now we have to solve. So this 2 will take common, and in bracket it will be PQ plus PR. And now you have to write PQ plus PR means what? So this means PQ, sorry, PR plus RQ. Okay, this is PQ. This is not PQ. Sorry, this is PR. Okay, PQ means this is RQ. RQ plus PR. RQ plus PR. RQ plus PR is actually a whole part of PQ. So you have to write the reason for this is since PQ is made up of, PQ means part of PR plus RQ. So you can PQ is equals to PR plus RQ. So hence proved. So therefore get number AD plus BC equals to 2PQ from statement 7. Okay. And this is hence proved.